be able to identify hydraulic symbols, understand a hydraulic circuit, identify GENIE hydraulic symbols, understand an open loop hydraulic circuit, understand a closed loop hydraulic circuit, define the term hydraulic schematic, understand the importance of hydraulic symbol placement in a hydraulic circuit. Read a GENIE schematic. A hydraulic schematic is a valuable tool and an accurate depiction of how a hydraulic system works. Being able to read and interpret a schematic can save a lot of time when troubleshooting hydraulic systems. Hydraulic symbols are a visual representation of how the component works. The hydraulic symbols are standardized by organizations such as the American National Standard Institute, or ANSI. When reading a hydraulic schematic, the components are identified by symbols. Let's start by relating the components you learned about in previous lessons to their schematic symbols. Here is the reservoir. The symbol used to represent the reservoir is a rectangle without a top. The symbol for a positive displacement pump is a circle with an arrow pointing away from the center in the direction of flow. The control valve shown in our basic circuit is a check valve. The check valve symbol is represented by a ball and seat. Check valves allow flow in one direction only. When fluid enters from the inlet side of a check valve, the check ball will unseat to allow fluid flow. If the fluid enters from the outlet side, the check ball will press against the seat and block the fluid flow. The actuator shown in our example circuit is a single acting cylinder. Here are the symbols that represent the components in our basic hydraulic circuit. When reading a hydraulic schematic, solid and dashed lines identify hydraulic lines, hoses, and assemblies. These are the three common line symbols. The main line is a solid line that indicates a standard pressure or return line. The pilot line is a dashed line that indicates where a pilot pressure line is present. The last type of line is used to outline a component assembly that contains multiple components. This line can be displayed two different ways as shown on the screen. Looking at the graphic on the screen, can you see the three different types of lines? In hydraulic schematics, there will be lines that cross each other. To determine if the lines are connected, look for a small dot at the intersection point. If a dot does not appear, the lines are not connected. If there is a dot in the middle of the intersection, then the lines are connected. When a line branches off another line, it is referred to as a T-circuit and they are connected whether a dot is present or not. Looking at the graphic above, can you determine what lines connect and which ones don't? Here we have recreated this circuit with the use of hydraulic symbols. You can see that the hydraulic schematic is a representation of a hydraulic circuit and how it works. Symbols represent components. An entire schematic represents the entire hydraulic system. Here are a few examples of complete valve symbols. We will simplify them in the following pages. Control valves can have multiple fixed positions, or proportional positions. Let's look at a three-position directional valve. Position 1, port A, and port B, are blocked. When the spool is shifted to position 2, port P is connected to port A, and port B is connected to T. When the spool is shifted to position 3, port P is connected to port B, and port A is connected to T. Valve positions are represented by individual boxes. Single box represents a single acting valve. A double box indicates a two-position valve. Three boxes represent a three-position valve. Pressure-compensated proportional valves are represented by two lines that run parallel to the valve position boxes. Port connections of a valve are depicted by arrows inside the position boxes. Flow path arrows, or ways, are also shown inside the position boxes. Methods of valve operation are spring held. An adjustable spring has an arrow running diagonally through the spring symbol. Mechanical, or manually actuated. Pilot operated. Solenoid operated. A solenoid operated, proportional valve has an arrow running diagonally through the solenoid symbol. An arrow running diagonally through any symbol indicates it is variable, or adjustable. Valve examples: pilot operated. Adjustable relief valve. Two-position. Three-way. Solenoid operated. Spring return valve. 3-position. 4-way. Spring-centered closed. Solenoid-operated valve. On this page we are showing 4 different center positions for 3-position 4-way valves. Closed center where all 4 ports are blocked. Open center, where all 4 ports are connected together. Float center, where ports A, B, and T are all connected. Tandem center, where ports P and T are connected. Flow control valve symbols are visually depicted by a restriction, fixed restriction, or orifice. The symbol will be shown on the schematic, with the size of the orifice. Needle, or shutoff valve, is shown as variable by the diagonal arrow running through the orifice symbol. The fixed orifice and the variable orifice are not pressure compensated, meaning that the flow rate across the valves are affected by pressure and oil viscosity. Pressure compensated valves are shown with an arrow crossing perpendicular to the flow regulated port, meaning that the flow rating of the valve is not affected by pressure or viscosity. The symbol will be shown on the schematic with the maximum flow rating. A proportional valve is a variable orifice that changes size in proportion to the amperage across the solenoid. The valve is shown as a 2-position because it is closed in the spring-held position. This 3-position, 4-way valve is both directional and proportional to control the speed and direction of the function with one component. The lines parallel to the valve represent pressure compensation, so the amperage to flow rating is not affected by pressure or viscosity. It is shown as proportional with the diagonal arrows through the solenoids. Let's look at the basic symbols found in GENIE mobile hydraulics. The following components are indicated in a hydraulic schematic by the symbols shown: reservoir, filter, pump, motor, single-acting cylinder, double-acting cylinder. Take a few minutes to review the symbols before you continue. Just like the previous page, these components are indicated in a hydraulic schematic by the symbols shown. Check valve, adjustable relief valve, adjustable sequence valve, pressure switch, pressure reducing, solenoid operated directional control valve. The remaining symbols that are found in a basic hydraulic schematic are directional proportional valve, solenoid operated flow control valve, fixed orifice, variable orifice, and a pressure compensated flow regulator valve. In an open loop system, the exhausted flow from the actuators or valves returns to the reservoir. An open loop system is common on all of GENIE's products. An example of a GENIE open loop system is the drive circuit on a scissor lift. In this example, a fixed displacement pump supplies the flow. In the first state of this example, the fluid travels through the hydraulic hose to the P-port of the manifold. If the 3-position, 4-way valve does not shift, the fluid cannot be directed to the drive motors, and it is returned to the reservoir. In the second state of this example, the 3-position 4-way valve shifts, directing the fluid to the drive motors. The drive motors rotate. The fluid exits the motors and returns through the tank port of the directional valve. The fluid returns to the reservoir through the filter. Another example of a GENIE open loop system is the lift circuit on a scissor lift. In this example, a fixed displacement pump supplies the flow. The fluid travels through the hydraulic hose to the P-port of the manifold. The 2-position 4-way valve shifts, directing the fluid to the single-acting lift cylinder. The lift cylinder extends. Any fluid that exits the rod end of the cylinder will return through the function manifold and filter to the reservoir. In a closed-loop system, the fluid exhausted from the actuators does not return to the reservoir as it does in an open-loop system. Instead, the fluid returns back to the inlet side of the pump. As you can see, in a closed-loop system, in order to change the direction of the actuator, a bidirectional pump is used to change the direction of flow. The pump flow changes according to the operator's demand. If the circuit pressure exceeds the setting of the relief valve, the fluid relieves back to the low-pressure side of the closed-loop system. The control valves in a closed-loop system do not return fluid to the reservoir. GENIE's typical closed-loop systems are comprised of piston pumps and piston motors. As these components are designed to leak fluid into the cases, case drains are added and depicted on the schematic with dashed lines. A charge pump is added to make up for the fluid lost over the case drains. The charge pump pressurizes the closed-loop system to the charge relief pressure on startup. The low pressure or return side of the closed-loop system is pressurized to the charge relief pressure as long as the case drain flow does not exceed the charge pump flow. In a GENIE closed-loop system, the pumps and valves are incorporated into a single assembly as represented by the thick dashed line.